We are from Roy's Academy faculty team, and today we'll learn course CBSE Class 10, Subject, Mathematics, Chapter 5, Arithmetic Progressions. Topic, Arithmetic Progressions Definition and Common Difference. For obtaining similar video explainers, please connect Roy's Academy at 8910-890311. Repeating the number again, 8910-890311. Our another number is 8910-600-503. Repeating the number again, 8910-600-503.
All right, so here's our game plan for today. First, we're going to put on our detective hats and hunt for a hidden pattern. Then, we'll give that pattern its proper name. After that, we'll break down the essential tools you'll need, figure out if these patterns can go on forever, and finally, we'll learn a surefire test to spot one in the wild. Let's get started.
Okay, first things first. Before we dive into any formulas or definitions, let's have a little fun. Let's become pattern detectives. Our mission is to look at a few lists of numbers and figure out the secret rule that connects them.
So, that's the big question I want you to think about as we look at the next slide.
Take a good look at these lists. They seem pretty different, right? You've got one that's just simple counting, then you've got another where the numbers are getting smaller. We've even got negatives, and one list where the number doesn't change at all. So what's the one simple rule that could possibly connect all of these? How do we get from one number to the next?
Okay, let's start with the easiest one, list I. 1, 2, 3, 4. Yeah, that's pretty clear. We're just adding 1 each time to get the next number. Simple as that.
Now, what about that second list? 100, 70, 40. The numbers are going down. To get from 100 to 70, we subtract 30. From 70 to 40, we subtract 30 again. So the pattern here is that we're consistently taking away the exact same amount each step.
And here's the big reveal. This is the secret that connects all of those lists. In every single one, to get the next term, all we're doing is adding a single fixed number. Think about it. In the first list, we added 1. In the second, we subtracted 30, which is just adding a negative 30, right? And in the list of all threes, we were just adding 0. It's the same rule every time.
Now that we've cracked the code and found the hidden pattern, it's time to give it its official mathematical name.
This special kind of pattern is called an arithmetic progression, and you'll usually just hear it called an AP for short. The definition is exactly what we just figured out through our detective work. It's a list of numbers where you get each new term just by adding a fixed number to the one before it.
And that fixed number we keep talking about? It has a special name too. We call it the common difference, and we represent it with the letter D. And what's really important to remember is that D can be positive, making the numbers go up. It can be negative, making them go down, or it can even be 0, which means the numbers don't change at all.
So, if you ever wanted to build an AP from scratch, you only need 2 key things. Think of them as your essential toolkit for making any arithmetic progression you can imagine.
This slide really shows you the power of D. In both examples, our first term, which we call A, is 6. Now watch what happens. When our common difference D is positive 3, our list grows, 6, 9, 12, and so on. But if we just flip the sign and make D negative 3, the whole progression changes direction. 6, 3, 0, negative 3. It's a completely different sequence, all because of D.
And this right here is the master recipe for any AP. You start with your first term, A. The next one is just A plus D. The one after that, you add another D, so it's A plus 2D. Then A plus 3D, and on and on. So the bottom line is, if you know your starting point A and your common difference D, you can build the entire list.
All right, let's tackle a new question. We know what an AP is, but do they all have to stop at some point, or can they just keep on going forever?
Well, the answer is they can do both. An AP can be finite, which just means it has a final term, a clear endpoint. You know, like a list of prize money amounts that eventually stops. Or an AP can be infinite, which means it never, ever ends. It just keeps on going, like the counting numbers from our very first example.
Okay, now for the really practical part. Suppose I gave you any random list of numbers. How can you be absolutely certain it's an AP? Well, there's a simple, foolproof test you can use every time.
Here it is, the golden rule. For a list to be a true AP, the difference between any two terms that are right next to each other must always be the same. Just pick any term and subtract the one right before it. If you keep getting the same number over and over, you found an AP.
So let's put this rule to the test. What do you think? Is the sequence 4, 10,
16, 22 in AP? Let's do the check. Second term minus the first. 10 minus 4 is 6. Okay, next pair, 16 minus 10 is also 6. Let's just do one more to be sure. 22 minus 16, and yep, it's 6 again. The difference is constant.
So, the verdict is in. Yes, this is definitely an AP. Its common difference is 6, and once we know that, we can easily find the next terms. Just add 6 to 22 to get 28, and add 6 again to get 34. See how that works?
Okay, time for another test. This one looks like a pattern. -2, +2, -2, +2. But is it an arithmetic progression?
Let's run our test. Second term minus the first. 2 minus -2. Remember, that's the same as 2 plus 2, so we get 4. Now for the next pair, -2 minus 2. That gives us -4, and we can stop right there.
The verdict is clear. No, this is not an AP. Since +4 is not equal to -4, the difference isn't constant. This list fails the golden rule.
So let's wrap this up. When it all comes down to it, what is the one single crucial check you need to perform to know for sure if a list of numbers is an AP? You got it. Check if the difference between consecutive terms is always the same.
This was an initiative from Roy's Academy faculty team, and today we've learned on course, CBSE Class 10. Subject, Mathematics. Chapter 5, Arithmetic Progressions. Topic, Arithmetic Progressions, Definition and Common Difference. For obtaining similar video explainers, please connect Roy's Academy at 8910-890-311. Repeating the number again, 8910-890-311. Our another number is 8910-600-503. Repeating the number again, 8910-600-503.